Soft computing. Soft computing refers to the consortium of computational technologies like fuzzy logic, neural network, genetic algorithms. So all these technologies, they are in conjunction or in combined way called as soft computing. Why? We'll see. Because all these have their roots in artificial intelligence, AI, may it be fuzzy logic or neural networks or genetic algorithm. They are rooted to AI. AI is what? This is a area. Actually, AI is an area which is related to computer science. When we are dealing with computer computing devices or computers which are intelligent enough to understand and make decisions. So we are designing intelligent computer systems. That is why we are talking that this is this computing device is intelligent, or we say the intelligence with respect to or compared to humans. They a device has certain intelligence which is given to it or it performs, which is artificial. So systems that exhibit the characteristics we associate with the intelligence in human behavior. What I indicated was it is related to what we think. See, we can make decisions maybe because of our IQ or with respect to our prior experiences. We can take certain decisions on certain issues. But what about a machine? Machine cannot take decision. But how and the way we can make a machine to take decisions by themselves. So this is artificial intelligence. And I said again, let me reiterate that AI is been rooted to fuzzy logic, neural network, and genetic algorithms. Soft computing was introduced by Mr. Zede of the University of California, US. The soft computing is soft. That means it differs from hard computing because it has tolerance of imprecision, uncertainty, and partial truth. When you talk about zero and then one in digital, just understand digital. Okay, let us take an example. So zero means say a switch is off, one means switch is on. Can you imagine, or there can be a possibility that neither switch is on nor switch is off. So there is certain in between characteristics. How to define that? How to model it? How to analyze it? This is the imprecision. This is the uncertainty and the partial truth. So soft computing has high machine IQ. We have IQ is people, their intelligence has a parameter or say a measurement. We call them he has a good IQ or he is less in IQ. But soft computing has high machine intelligence question. So it is the processes of analyzing, organizing, and converting data into knowledge, which is defined as the structured information acquired and applied to remove ignorance and uncertainty about a specific task pertaining to the intelligent machine. As you said, it is a hybrid system. What hybrid system can be? This is neural network, genetic algorithm, fuzzy logic. This area is the neurofuzzy. This area is this whole area is the neurogenetic algorithm. This area, whole area, is the genetic algorithm, genetic algorithm, and this area is neurofuzzy genetic algorithm. So let us begin with the neural networks. Neurons, you have neurons in your brain. So how this neuron they become intelligent, or how they make you intelligent. If you are a kid just born, you don't know anything. As you grow up, you start understanding, and you are mature or adult. You understand everything. You are given a right to vote. You can decide. So now here, your neurons are well built. So it is a simplified model of the biological nervous system. Therefore, have drawn their motivation from the kind of computing performed by human brain. Human brain. It is as highly interconnected networks of a large number of processing elements, which we call as neurons, and the architecture is inspired by the brain, where we have number of neurons every time they are getting experience, every time they are giving feedbacks and making our brain intelligent. So it can be massively parallel, so it exhibits the parallel distributed processing. Neural network learn by examples, learn by experience, learn by what we can call as feedback. So we train with known examples of a problem to acquire knowledge about it. This trained network can be put to effective use to solve the unknown or untrained instances of the problem which has not been given to it. Just by prior experience, neural network may be able to solve the or can think about the unthinkable. Then the supervised learning. What is supervised learning? If the learning is done in a supervised manner, we call it as supervised learning. What is it? A teacher is assumed to be present during the learning process. Means there is someone there which is supervising. So a network aims to minimize the error between the target output presented by the teacher and the computed output to achieve better performance until unless the difference or the error becomes zero or minimum as possible. Unsupervised learning. In this, there is no teacher present to hand over the desired output, and the network therefore try and try again to learn by just itself organizing itself the input instances of the problem. So, what is neural network architecture's classification? It can be single-layered feed-forward networks, feed-forward, multi-layered feed-forward. You can have multiple layers in between. You can have recurrent networks. So these are the ways. So what are the application areas of neural network? It is employed in pattern recognition, image processing, the data compression, the forecasting, optimization, stock market prediction. Neural network system, also the back propagation network, that is the output is given to the input just to minimize the error. We have perceptron in between, the adaptive linear element, the associative memory, and Boltzmann machine with adaptive resonance theory, self-organizing feature map, and Hopfield network. These are the neural network systems well known. Then we come to the fuzzy logic. It tried to capture the way human present and reason with a real world knowledge in the face of uncertainty. Uncertainty means loss of, there is no generality, there is some vagueness or some ambiguity or chance of incomplete knowledge. So the capability of fuzzy set to express the gradual transitions from membership to non-membership and vice versa has a broad utility. Operations on fuzzy sets, you can apply union on fuzzy set. Fuzzy logic is by itself another mathematics which deals with the fuzzy, that means the value which is in between the mathematical values, union, intersection, subsethood, composition of relationship. So fuzzy logic, multi-value truth values can be true. Now true and false, but fuzzy can be absolutely true, fairly true, and then false. Also absolutely true, or partially true, or partly true. Fuzzy logic, washing machines. These machines offer advantage of performance, productivity, and simplicity. Productivity and less cost. Sensors in the fuzzy continuously monitor varying conditions, different conditions inside the machine, and they adjust accordingly for your best wash. And typically, fuzzy logic controls the washing process, water intake, water temperature, wash time, rinse performances, screen speed. So what it does, this optimizes the lifespan of the washing machine. We have more sophisticated machine, way to load, advise on the requirement amount of detergent, assess cloth material type, water hardness, and also check whether the detergent is in a liquid or a solid form. Some machine even learn from past experience. It can memorize the programs and then may adjust just to minimize the running cost. Then we come to the genetic algorithms. It is initiated and developed by John in early 1970, John Holland. These are unorthodox search and optimization algorithm, which mimics some of the processes of natural evolution, genetic algorithm. So this GA perform random searches through a given set of alternatives with the aim to find the best alternative with respect to the given criteria of goodness, the given criteria of being good. So these criteria are required to expressed in terms of an objective function, which are usually referred to as the fitness function. So genetic operation involves the reproduction, crossover, mutation, inversion, the dominance, the deletion, the duplication, the translocation, the segregation, the speciation, migration, sharing, and mating. Applications of genetics in robotics. For example, robotics involves human designers and engineers trying out all sorts of things in order to create machines that work like humans. Each robot is designed independent of the job and job it is supposed to do. So there are many different designs present. GAs can be programmed to search for a range of optimal designs and the component for certain specific use, or to return results for entirely new or novel type of robots that can perform multiple tasks, and they may have general application also. GA design robotics just might get us those nifty multi-process learning boards we have been expecting for years now, and these are ready, these are available. So this was a very, very brief introduction of soft computing. We'll be taking more. Thank you so much. Take care.